Good morning, class. Today we're going to look at rationalizing denominators with higher roots order, which means instead of looking for a group of 2, we're looking at a group of 3, 4, or higher. All right? Let us see what we're looking at. We know last time we had to devise something like this or rationalize something of this form. Remember, of course, we multiply everything by 1 because we're not changing the value of this expression. We multiply it by 1, and of course, we multiply it by a square root of 3 over the square root of 3, but why? Remember, the goal is to get square root of 3 from the bottom. Now, the reason that is so, if you look at the bottom radical expression, which is the denominator, this tells us we need a group of 2. The reason that is, since we need a group of 2, to get rid of the radical sign, we need another 3. That is the reason we multiply by another square root of 3, so we can have 2 on the bottom. So it goes like this. And if we do that, we get the following. So now we have the group of 2, and we can get rid of the radical sign on the bottom. Okay? That is how this is done. Now, we have to think in the same manner if the root was cube root, fourth root, and so on. So, let us look at this. If in this case they're asking us to have a group of 4, but how do I do that? The best thing to do, take the radicand in the denominator and break it down. Here's what happens. I have a 2, I have only one 2, and I have 2 3s. So that doesn't work. In order for me to get rid of that, I need 4 2s. So I need 3 more 2s to make it 4. And I need 4 3s as well. So I need 2 more 3s. So I need 3 more 2s and 2 more 3s. So let's look at it. What would we have? So that would, if I have 3 extra 2s, that would make the 2 a group. And 2 more 3s, that would make another group of 3s. So I can get rid of the radical sign in the denominator. So that looks like, if I multiply that, I get 72. So as a result, even though I'm going to multiply this by 1, I'm going to multiply by the 4th root of 72 over the 4th root of 72 in this case. You see? And of course, we're going to multiply. And now, notice the bottom, I simply break down the factors because I'm going to look for the group of 4. The top, I know that I wouldn't find the group of 4 into the 72 because after all, we picked it up. We know it has 3 2s and 2 3s. So there isn't any group of 4 there. So on the bottom, we combined it with the factors of 18. Remember, 18 had 1 2, and plus we put 3 2s, so that gives us 4. And 18 had 2 3s, and we put another 2 3, that gives us another group of 4. Ladies and gentlemen, this is what the factors of 72s are. So with the factors of 18. That's what's under the radicand. The radical sign, excuse me. So now we have a group of 2, which is there, which means 2 goes out, and a group of 3, which means 3 goes out. So that got rid of the 4th root sign that we have there. So we have 2 times 3. As a result, It is 7 times the fourth root of 72 over 6. That is our answer. I want you to understand that concept here. Let us look at another. Again, remember, I want to rationalize the denominator. So I'm going to see the factors of 14. 14 has 1, 2, and 1, 7. Here's the thing. But this tells me I need group of 3s. To make that happen, I need 2 more 2s and 2 more 7s. So if I have 2 more 2s to make a group of 3 of 2, and 2 more 7, a group of 3 of 7, that number is 196. So I'm going to multiply the expression by 1 by multiplying by the cube root of 196 over the cube root of 196. In this manner, we have the following. You see? And now, what we end up with, ladies and gentlemen, we have the top, that's the first 2 2s from the 4, because the reason I factor the 4, because we can find group of 3s in the numerator once we multiply by the cube root of 496. So we put the factors of 496 on the top also, and we end up with the 2277. To join the factors of the 4, that's 2, 2. And we do the same thing on the bottom, the factors of 14 with the factors of 196, and we have the following. As a result, remember, in this particular problem, we are looking for group of 3s. And here we have it. Now on the top, in the numerator, ladies and gentlemen, we have one group of 2, which means 2 gets out, multiply the -7, which is the coefficients. So, ladies and gentlemen, and we end up with the following. Okay? And on the bottom, of course, that was our goal, to get rid of the cube root sign. So there's the 2 that's out already, and we have the following. We have this, the 2 and the 7, which you can simplify right away. If you simplified it right away, you would cross out the 7 and 7 and the 2 and the 2. So you would have a -1 as the coefficient on the top. That's the best way to go, actually. But for purposes, I multiply the coefficients and so forth. Then we now have to simplify it, divide both the numerator and the denominator by 14, and you have negative cube root of 98 over 2. This is it, ladies and gentlemen. Please, make sure you understand the procedure of such a operation. When you have to rationalize the denominator with a variable, the steps don't change. The steps remain the same. It's just, you're just dealing with variables. Simple as that. So, again, we're looking for a group of 4s. Let's look at what we have. We look at the bottom radicand, and we see 1, 2. That means we would need 3 more 2s. We have 1x, that means we would need 3 more x. We have 3 y's, that means we would need 1 more y. So what we would need is the following, which is 8x cubed y. That's what we're going to use to multiply the expression by the 1 without changing its value. And we have the following. So once we multiply, because it seems we're going to have group of 4 both on the top radicand and the bottom radicand, so we use the factors. Once we multiply them, of course we keep the 2x, which is the coefficient, and the first 8 has the 3 2's, and we know we're going to bring 3 more 2's for the other 8. So we group them like this. And the top has 1x, and we bring 3 more x and a y. In the denominator, we have the following. Of course, we're going to have 4 2's for x, for y, because we pick the radicand that would complete the group of 4 so that we can get rid of the fourth root sign in the denominator. And ladies and gentlemen, we have a group of 2, a group of x, so 2 and x goes there. Then what remains is the fourth root of 2 times 2 and y. Similarly, on the bottom we just have groups 2x and y. Let us go ahead and simplify right away. Here we have it, and we end up with the following. 2x cube root, fourth root of 4y, and ladies and gentlemen, over y. Remember, we do not want a 0 in the denominator. Hence, y does not equal 0. And that's all there is to it. Make sure you understand, and you can complete these questions. You can complete tasks to such nature by yourself. All right.